All right, let's look at the homework 13, problem number 7. All right, so we want to find the volume in the first octant bounded by the coordinate planes and the plane x plus 2y plus z equals 4. All right, so let's draw a picture. All right, so we have the x-axis going like that, and the y-axis, and the z-axis. Right. So since this is a plane, if you have 3 points, then we know exactly which plane we're looking at. Right. So let's find the intercepts. For example, if you want to find x-intercept, so what you do is you can set to y equals 0 and z equals 0. So we can see that x-intercept, so maybe I'll just write that, x-intercept is going to be, put 0 there, put 0 for y and z, so x equals 4. Right? How about the y-intercept? It's going to be, put the x equals 0 and z equals 0, so 2y equals 4, so it has to be 2. Right? And the z-intercept, and put x equals 0, y equals 0, so z equals 4 as well. Right? So which means that it's going to go through, let's see, x equals 4, so 1, 2, 3, 4, so x equals 4, so it's going to go through there. Right? Then y equals 2, so it's going to be 1, 2, so that's 2 there. Right, so it's going to go through there. And then z equals 4, so 1, 2, 3, 4. So that's 4 there, and it's going to go through there. Right, so you would have a plane kind of go like this. Making sure that it's going through those 3 points, right? So this is a plane this is a plane x plus 2y plus z equals 4, right? Then also it's cutting by the coordinate planes. Then you can see that it's the solid in the first octant is gonna probably look something like this. So it's gonna, just gonna connect those dots there. Right. So this face is going to be on the plane x plus 2y plus z equals 4, and everywhere else is surrounded by the coordinate planes. So you can see that the solid is this guy right here. So this is the back side, right? This is the back side too, and this is the bottom side. And then you have a face here. So I don't know how to, I'm going to just shade it like this. Right, so this is the shape. Right, then we want to set up an integral. Right, so let's do that. Right, so we want to find the volume V. Right, then we want to set up a triple integral. You can do a double integral too. Right, so let's do a triple integral, and let's do dz first, derivative with respect to z first. So then we can do either x or y. So I'll probably just do dy and dx. How about that? Right. So we want to fix. So we want to fix x and y. Right. For fixed xy. So here is x value, so x value is fixed and the y value is fixed. So we're talking about, right, so the point So for a fixed x value, right here, x and y value, right? So z value is going to start from the xy plane all the way up to wherever it hits the plane, x plus 2y plus z equals 4, right? So we know that here z equals 0 is that, right? Then we can actually solve this equation for z. So this guy, solve this equation for z. So z is equal to 4 minus x minus 2y, right? So z equals 0, which is the xy plane, all the way up to z equals 4 minus x minus 2y, right? And once you've done that, we're gonna fix x, right? So fixed x here, right? Then you want to go from y is gonna start from here all the way to this line here, right? So we have to come up with the equation for that line, right? So we have this guy, right? So let's see, we want to, so this is the line, so maybe I should just extend the line so that we can see it. So here's the line. Alright, so we just have to find the equation. So I guess y is equal to, right, y-intercept is 2, so we already know that. Let's see, maybe I put the plus 2 here. Alright, then we just have to find the slope. Alright, so slope is going to be, as you go to 4 units, you actually come down 2 units. So it's going to be negative 1/2. Alright, so this is y equals negative 1/2. Alright, so for fixed x, y is going to start from 0. Alright, so which is here. So start from y equals 0 all the way to y equals negative 1/2 x plus 2. Right? So we have that. And once you've done that, so that will take care of basically this triangular region. Right? And kind of like a cross section parallel to YZ plane. Then we just have to start from this guy right here, which is the x equals 0. So x equals 0 there. And all the way up to, so you just cover the entire solid like this, and all the way up to x equals 4. So it's 4 goes there, right? So that's how you set up the triple integral. Then I let you guys compute the triple integral. All right, that's it. I hope that this was clear.